Similar shapes in 2 dimensions and similar triangles. So intuitively, 2 shapes are similar if they have the same shape, if they're different size, and therefore they have to have a scale factor. And the scale factor describes how big or small one shape is compared to another. So an enlargement is a scale factor bigger than 1, and a reduction is a scale factor smaller than 1. So in other words, a fractional scale factor. The scale factor is also known as the length scale factor, LSF, or we often write it using the letter K to signify the scale factor. 2 shapes are congruent if they have the same shape and the same size, so K equals 1. Now for a linear scale factor, 2 two-dimensional shapes are similar if the ratios of all the corresponding sides are equal. So given 2 similar shapes, we can identify which shape, the smaller or the bigger, has the missing side and work out K, and then the missing length, L new, is worked out using the corresponding length on the other shape, L old, using the formula L new equals K, the scale factor, times L old. So the first example here is, are these 2 rectangles similar? And we need to justify our answer. Now you can see we've got 2 rectangles. The bases on both of our rectangles are the longer sides, and the heights of our rectangle are the shorter sides. So let's look at the corresponding sides to work out K for each pair of sides and see if they're the same. If the scale factors are the same, then the triangles are similar. If the scale factors are not the same, then the triangles are not similar. When it says justify your answer, you cannot just answer these questions with yes or no. You must have some sort of calculation. So we're going to work out K for the big one over the small one. And we're going to get a scale factor of 2 for the bottom edges of our rectangle. Now, if we look at the sides, so let's change the color. So we're going to look at the sides. These are the corresponding sides. And so we're going to say that K for these corresponding sides is, again, we need to do the same way round. So 6 over 2, and that equals 3. So the answer to my question, are these 2 rectangles similar, is no, they're not, because no, rectangles not similar as values of K different. In other words, 2 doesn't equal 3. So what about these 2 rectangles? Are they similar? So we're going to do the same process. We're going to look at the corresponding sides. So we're going to look at these bases, and this time we've got 21 over 7 equals 3. And then we're going to look at the other corresponding sides, and this time that's 6 over 2, and that gives us 3. So our scale factors are the same. So these rectangles are similar. As K values are the same, or our scale factors are the same. Now for triangles only, there's another way to describe similarity. Triangles are similar if any 2 pairs of corresponding angles are the same. So let's have a look at an example in action. Are these 2 triangles similar? Justify your answer. So you can see we've got triangle ABC, and we've got triangle DEF. Angle B is 97 and angle E is 97. Angle C is 21 and angle F is 21. And if we wanted to, we could work out what angle A and D are using our knowledge of a triangle, that all the angles in a triangle add up to 180. But as I said in the previous slide, we just need to have two pairs of corresponding angles. So are these two triangles similar? We can say that angle B equals angle E equals 97 degrees, and angle C equals angle F equals 21 degrees. Therefore, two triangles are similar. So make sure that you answer the question in these types of questions. So the next example is asking if these two triangles are similar, and we need to justify our answer. Now you can see now we don't have two pairs of corresponding angles. We can start off by saying that angle C equals angle F equals 21 degrees because they are corresponding, but angle A is corresponding with angle D, and we don't know what angle D is, and angle B is corresponding with angle E, and again we don't know what angle B is. So we need to work out what the missing angle is. So let's work out what angle B is. So angle B is going to be 180 take away the sum of 63 plus 21. So that's 180 take away 84. And that gives us an angle B of 96. So if we write that onto our diagram, you can see there that angle B does not equal angle E. So angle B doesn't equal angle E. Therefore, triangles are not similar. So we've worked out how to work out the scale factor. Now we want to use it. So if you remember, our formula for working out what the new length is was L new equals K times L old, where L new and L old are the corresponding sides. So we need to work out what K is, and we can only work out K with corresponding sides. So I'm going to work out K using the corresponding sides, the 9 and the 6. Now, my missing side is on the larger triangle. So that means when I'm working out my value for K, I have to put the new over the old. So K is going to be 9 over 6, which I can simplify down to 3 over 2. Now, what I'm going to do is I'm going to write my formula. So y is going to equal 3 over 2 multiplied by 10. And so y is going to equal, and remember, a whole number is a fraction over 1. We're going to multiply the tops together, and that gives us 30. And we're going to multiply the bottoms together, and that gives us 2. And then we can work out that 30 divided by 2 is 15. And so we've worked out the value of y. And if we do 15 over 10 and simplify it, we will get a k value of 3 over 2, so we know that we've got the correct value. Now, sometimes we're using our knowledge of parallel angles. So here we've got a picture with some values written on it. We want to calculate p to 2 decimal places. And so the first thing we're going to have to do is work out what our triangles are. And you can see I've marked on your equal sides. But you can see that the x's are what's called vertically opposite, so they're equal. So if we draw sketches of our two triangles, we've got P and 15 on one of the triangles. And then we've got 19. And we know that the x's are at the top of both of my triangles. Now, if you think about your Z-shaped angles, you can see that that is why the O marked angles are the same. So you can see that the O angle is down in this bottom corner. So that means that the side that's missing on the triangle with a base of 19 is 13. And so those are my corresponding sides. And if I want to, for completeness, mark in my square, then I can do. So my missing value this time is on the smaller triangle. So I'm going to find my k value by doing 15 over 19. And then to work out p, I'm going to take my 15 over 19, I'm going to multiply it by 13. Now 15 times 13 is 195 over 19. And if I want to round that to 2 decimal places, remember always write more than 2 decimal places and then do your rounding. So I had 10.2631 and to 2 decimal places, that's going to turn into 10.26. The final example has another parallel line. This time it's asking us to work out the value of, or the length of a dB. So that's from here to here. Now, we can't do that all in one step. What we're going to have to do is we're going to have to work out what BT is. So we want to work out what this value here is, and then we're going to be able to add it on to the 144 centimeters to get the total length of BD. So again, draw yourself some sketches. So we've got triangle DCT, and then we've got a littler triangle, and we need to work out how the letters go. Now you can see that with my Z-shaped angle, angle B and angle D are equal. So this is B over here. Angles at T are both equal because they're vertically opposite. And then using my Z-shaped angle, angle A and angle C are both equal. So my angle A is going to be over here. So now I can put the sides onto my triangles. So I know that TD is 144. I'm going to leave the centimeters off at the moment because my scale factor won't have a unit. My TC is 160 centimeters. Now on my other triangle, TB or BT is X. I've called it X. And AT or TA is 120. So my corresponding sides are 160 and 120 to work out my scale factor. Now, my missing values on the small triangle, so therefore I'm going to say that K equals 120 over 160. And I can simplify that down to 3/4. And now to get X, I'm going to take my 3/4 and I'm going to multiply it by 144. And that gives me 108, and my units are centimetres. And I can double check, if I do 108 over 144, then I get a scale factor of 3/4 when I simplify my fraction.